This picture is of the wave at a single moment in time, as if we've taken a snapshot. The shape of the string, then, is known as the wave form. In this case, it's a sinusoidal wave. It doesn't have to be, but the mathematics works out very nicely for sinusoidal waves, and that's what we will focus on. We know that this disturbance is moving continually to the right here, but we've looked at it at just one point. Now, this line in the middle represents the point of zero displacement. Up here at the top is the point of maximum displacement. We have a name for that point of maximum displacement. It's called the peak, or crest. The bottom here is known as the trough. The distance from zero displacement either to the top, the crest, or from zero to the trough, either one of those is known as the amplitude, and amplitude is either written with a capital A or capital letter representing whatever variable is changing. So in this case, we're moving in the y direction, so we would use a capital Y. Now, you're familiar from simple harmonic motion with the terms period, capital T is period, which is the time to repeat itself, and frequency F, which is the number of periods, number of cycles, in a fixed time. Well, we have similar ideas for a spatial variation like we have in a wave. In simple harmonic motion, it only varied in time. Here it does vary in space. So the distance for a cycle, instead of the time for a cycle, that's the distance from peak to peak. And it's known as the wavelength, written with a lowercase Greek letter known as lambda. Let's make a little more space here. And that's the distance for a cycle. Now, one thing to note about wavelength, it can be from peak to peak. It can also be from trough to trough. We don't have another trough here, but it would be the same distance. It can also be from the middle pointing up to the next place we have the middle pointing up, or from middle sloping down to the next place we have the middle sloping down, or from halfway up sloping up to halfway up sloping up, or halfway up sloping down to halfway up sloping down. The key is that you have to be the length for a complete cycle. And to be at a complete cycle, you have to come back to the same place in your waveform. So it can't just be at the middle, back to the middle. It has to be middle sloping up to middle sloping up. One more point here. You see the man is moving his hand up and down. As a result, every place on the string is moving up and down. The string is not moving to the right. It's moving up and down, and the disturbance is moving to the right. That's what makes this a transverse wave. And it's sinusoidal because the shape is the shape of a sine curve.